Hello, this video is section 7.4 from the Larson book, Hypothesis Test for Proportions. Now we will only be using z-test for proportions. There won't be a distinction between z or t. It's only z, but yet it still must satisfy these conditions like it did for confidence intervals. N times p greater than or equal to 5 and n times q greater than or equal to 5, where whether it's q or q hat, we'll talk about either way, 1 minus p or 1 minus p hat, where your p hat, your sample proportion, is still x divided by n. Now generally if n is large enough, it'll be no problem satisfying this, but here's an example where it doesn't. Suppose n is 8 and p is 0.45. And q then would be 1 minus 0.45, which is 0.55. So if you take 8 times 0.45, you get 3.6. 8 times 0.55 is greater than 4.4. They're not both, they have to both be greater than or equal to 5. Neither one of them are. So actually, after the first one failed, that pretty much meant the whole thing failed. So it would not be right to do this process for this problem using the normal distribution. I mean, there's really no other way we would attempt it anyway, so that makes it invalid. Okay. Now, here's this test statistic, which you won't really have to calculate, but I always like to show you where everything's coming from here. So now we've got a p hat, which will be our the sample proportion, and your p0 is your hypothesized value. And then the denominator is the square root of p0 times q0 divided by n. All right, so, but we'll be able to use technology to do that. So everything's kind of the same, where you have the idea of left-tailed, right-tailed, two-tailed, and it's just we're using p now instead of mu as your sample, as your population mean that we used before. That's the only difference. So everything else kind of is the same. The way you read it, interpret it, and set up the claims. You see how? Let's see what this one says. Research Center claims that less than 30% of its cell phone users whose phone stays connected to internet have done so while at home. So we're testing less than. Less than must be an alternative, of course, and that's the claim. And less than pairs up with greater than or equal to automatically. So you see, same process as before. And if we were being asked, this would be a left-tailed test, following those same guidelines that we had for the population mean as far as defining left-tailed, right-tailed, two-tailed. That's the same procedure, regardless of a new population parameter. All right, a sample of 85 adults, 17 say they have used their cell phone to connect to the internet. And at a 0.05 level of significance, is there enough evidence to support the researcher's claim? In other words, do we reject this hoe and agree with the alternative, and that would be the, oh, video's ready. We would support that claim. So here we go, let's see. Now, P0, or P hat, will be 17 divided by 85. And P0 here is your 0.3, therefore that makes Q0 1 minus 0.3. Now I didn't even bother working it out using the formula. Let's look at the calculator. And we go stat, test, it's number 5. So always a reminder here on the calculator, test means hypothesis test. interval means confidence interval. So yes, we used in 6.4, we used the, where it is, right there, the one prop z interval. That was for confidence intervals. This is for a hypothesis test for proportions. So our P0 is 0.3. X was 17. 85. And then we have to pick the correct alternative hypothesis. Just like we did using this for in the calculator for the mean. Same thing, you got to pick which is the correct ha, and it's less than. So we hit enter right there. Calculate. And we can use the p-value here to take care of this. And the p-value is 0.0221. And since 0.0221 is less than 0.05, we reject the hoe. And rejecting the hoe means we support the researcher's claim. Because remember, the claim was the alternative. So rejecting the hoe means we agree with the ha. So we support that. Using Excel. So on the hypothesis test, calculating hypothesis test value spreadsheet that's in D2L, come over to here. And you want to be over here where it says proportions. And type in what we need. I believe this was 0.05. I can double check, before I enter if I don't feel right about everything. 1785. Hypothesized proportion was I think it's 0.3. Let me double check. As in 30%. Yeah, 0.3. And you see what's happening here is doing all this. It's calculating the p hat and the q hat strictly from the x and the n. You don't have to calculate that. All you have to enter is just those first four numbers. It's doing everything else. It's giving you the test statistic. It's giving you the critical value. But there's the p-value, 0.0221. So that will, there it is right there. So same p-value that we got from the calculator, less than alpha, and we reject. So let's suppose that we were doing this by the critical value method. And obviously you have to reach the same conclusion. So the decision rule would be reject the hoe if z is less than negative 1.645. Left tail, we always reject to the left. Negative 1.645. Area left of that, since it's a one-tailed test, we don't divide by 2. It's just 0.05, 0, 1, paste. So 0.05 area to the left gives you negative 1.645. And you can see if you do this, if you use the spreadsheet to do it, it just gives you the critical value right there. And I just kind of drew a little graph here just to kind of show you, but negative 2.02 would be to the left of negative 1.645. Therefore, we reject the hoe. And we kind of already know that we're going to reject. So even if it's asking you a question using critical values, you can look at the p-value then and know for sure whether it's reject or not reject. But we like doing these both methods just to show you. But the p-value, even it wasn't asking for it, would be good to look at to make sure, because sometimes these negatives can get a little tricky, which one's smaller than the other. So the negative 2.02 definitely falls out here in the rejection zone. Here's another example. A Roper poll claims that 5% of U.S. adults have had vivid dreams about UFOs. You decide to test this claim and ask a sample of 250 adults whether they have had dreams about UFOs. Of those surveyed, 20 replied yes. At a level of significance of 0.01, is there enough evidence to reject the claim? So, like I said, any problem that you're asked to do this, to do a hypothesis test, I'm just showing you it satisfies these, but you can pretty much assume it's going to, unless, like I said, there may be a question where, just like we did early in the notes there, does this scenario satisfy it? And then the answer would be yes or no. But if we're doing a calculation, you can pretty much be assured it's going to. But here, I didn't show the results of these numbers, but 250 times 0.05 and 250 times 1 minus, hang on, that's wrong. Yeah, so that shows that actually it's 1 minus 0.05 is 0.95, but I did not have that written there correctly. So both of those, you can check them if you want to in the calculator, but they'll easily be greater than or equal to 5. So therefore that validates us using the normal distribution. So the claims that 5% of adults have the dream. So you don't want to read too much in it. You might be looking, well, are you saying more than 5%, less than 5%? If there's nothing indicating more or less, you just assume that means equals. In other words, we're just saying it equals that amount. So that's why this is going to be 0.05 equals, and that's our claim. And then the opposite of 0.05 would be equal 0.05 would be not equal to 0.05. All right. So now here's the N. I wrote the P hat. I'm not sure why I calculated the P hat. We don't really need it, because we'll be entering, whether it's Excel or calculator, we enter the value for the X and the N. So p-value method using the calculator. One prop z-test. And it was 0.05. And it was 20 said yes out of 250 interviewed. And we had to pick the correct alternative hypothesis here, which is not equal. Calculate. And you see everything's in the same screen right there to the right. So we have a p-value of 0.0295. That is greater than 0.01. So we failed to reject that hoe. We failed to reject the claim. But once again, does that mean we totally support the claim? No. It just means we don't have enough evidence to say it's wrong. So let's take a look at the Excel, and we have to determine whether it's left-tailed, right-tailed, two-tailed, which this was a two-tailed test. Scroll back up there just to check. And let's see, what was, oh, was this problem? Yeah, okay, excuse me. Just jumping ahead of myself here. All right. So it's two-tailed, right down here, 0.01 and 20 out of 250. Hypothesized proportion, what were you testing this against? It was against 0.05. And you can see that the p-value right here is 0.0295. And there I have it highlighted in yellow. And I went ahead and highlighted the critical values too, because we'll be using those to do the critical value method here in a second. Okay. Now to get the critical value in the calculator, you do the inverse norm, but you have to do it as divided by 2. If it's a left-tailed or right-tailed test, you don't have to divide by 2. It's just obviously, if it's a right-tailed test, you can still put the number there and just realize the value is going to be positive. But so you put 0.01 divided by 2, that's giving you the left number, and of course there's a positive number then that goes with that also. So our decision would be to reject the hoe if it's less than negative 2.575 or greater than positive 2.575. So I'm just kind of estimating about where 2.176 would be, and that's clearly in the fail to reject zone. And like I said, I didn't reprint the Excel. If you just look right up there, there are the critical values for you right there in Excel. And fail to reject. So always remember, they have to yield the same conclusion, both methods. You can't if you get reject by one method and fail to reject by another, you have made a mistake somewhere. All right. Pew Research Center claims that more than 30% of U.S. adults regularly watch the Weather Channel. You decide to test this claim and ask a random sample of 75 adults whether they regularly watch the Weather Channel. Of the 75 adults, 27 responded yes. At alpha equals 0.01, is there enough evidence to support the claim? All right. So more than 30%. So more than 0.3. So it's greater than 0.3. Greater than is always a ha, and it always pairs up with a ho of less than or equal to 0.3. And then this is the claim. Okay, so we're all set here. I just kind of wrote down some various stuff here, but we're able to go right to the calculator or Excel on this, whichever you prefer. So stat number 5, one prop z-test. 0.3 is our hypothesized proportion of those 27 out of 75 adults. 27, 75, and now important that we pick the correct, especially for the p-value. It'll give you the right test statistic no matter what, but it will not give you the right p-value. So how does that match what I already have printed here? Looks good. P-value 0.1284. So in Excel, I won't enter this one quick, so we'll see them in the homework, but so see I put 0.01, 27 number of successes, sample size 75, hypothesized proportion 0.3, so you only need to enter those 4 numbers, everything else from there is calculated. And there's the same there's the p-value, 0.1284. There's the critical value, so using the p-value method, whichever way you calculate or Excel, it comes out to be 0.1284. Well, 1.284 is greater than the significance level of 0.01, so we clearly fail to reject that hoe. So we're not rejecting the hoe, and therefore we cannot support the claim. Because we didn't see the claim being the alternative, we would have had to have rejected the hoe to support that claim. And the critical value, okay, I did this way in the inverse norm. Yeah, that's fine. I did 1 minus 0.01. That's okay. For a right tail test, you can do 1 minus. Or if you just do 0.01 and just understand that the answer is going to be positive. So I guarantee if you just put 0.01 in there, you'll get negative 2.333. But it's got to be positive because it's a right tailed, it's on the right side. But that going 1 minus 0.01 gives it to you exactly the right sign, positive 2.33. And you see the 1.134 test statistic, which is right there in the calculation, test statistic Z, 1.113. It's also down here in Excel, 1.1133. Either way, it does not fall, it's not bigger than 2.333. It falls to the left of it, so it fails to reject. So here it is in a statement. Now, there's not sufficient evidence to support the claim that more than 30% of the population watches the Weather Channel. All right, so that's the last example here. So I do believe that means it's homework time. All right, let's take a look at I have deleted a couple, I've removed them from the homework. Now in subsequent semesters, there may be 2 new problems there or whatever, but in the summer of 2023, this number 2 and number 4 have gone away because I can explain how to do it. This gives you a percentage instead of giving you an X and an N like the next one. A number over a number, it makes it easier to use the technology. So, like I said, in future semesters, people won't see that. It'll be just a regular problem when I go back and put 2 different ones in there. But here's what I'm talking about. You see, so this says sample of 260, 78 have changed jobs. That's the way I want it. I don't want that to be given as a proportion. I want it to be given as an X and an N to be able to use the technology. You can make it work the other way, but it's better this way. So here we go. All right, Research Center claims that more than 26% of its employees in a certain country have changed jobs in the past 3 years. Random sample of 260 from that country, 78 have changed jobs in the past 3 years. At alpha equals 0.10, is there enough evidence to support the center's claim? All right, so they're claiming more than 26%. So I like more than, and you see it's already got a percent format there, so we won't need a decimal. All right. Very good. And now we have to set up the ho and the ha. So it's more than, and more than is always a ha. So it's got to be B. So you got, like, for example, look at C. You know, you can't have, even though it's got the right 2 symbols, they have to be in the right position. You cannot have a greater than as the ho. So now we should probably put these in there as decimals, because you see it doesn't have a percentage thing after it. So let's go 0.26, 0.26. Fantastic. Find the critical value. Now this is a right tail test. So you can do this two ways. It's a right tail test, so your number is going to be positive. So if you want to put 0.10 in here and the answer is going to be negative, you just have to know it's going to be positive, or you can just go do it as 1 minus 0.10. And that means that automatically puts the value on the right side of the curve, and then you're set. And paste. 1.28. So it should be 1.28. Ta-da! Next question, rejection region. So that's our critical value, and it's a right-tailed test. So it's a right-tailed test greater than, and there's the 1.28 that we just got right above. Fantastic. Find the standardized test statistic. So also let me mention that you could have got the 1.28 from the Excel. And just as long as you pick right-tailed, we're about to enter all the numbers in Excel, but if you just, for example, if you just put the 0.10 only, the rest, for the critical value, the rest of the numbers do not matter. Right-tailed, 0.10, and you see right there at the bottom, there's your 1.28. So, yeah, the calculator way I showed you, here's the Excel way to show you. Now we're actually ready to do the calculation in Excel and the calculator. Test statistic. So let's come up here to the calculator, and let me kind of split screen this up here and put this one back up. And stat. So we're 0.26 is our P0 that we're testing against. 78, 260, and there it's already, the correct one is already highlighted over there to the right, greater than. And the test statistic right there is 1.47. Or how many decimal places does it want? Let's see. Two, okay. So 1.47. All right, so Excel. 0.26, 70 something, and 260. 78 and 260. Oh, no, sorry, excuse me, timeout. You're probably looking at that. Sorry. There's where the 0.26 goes. The hypothesized proportion. Excuse me. This is the 0.10, the level of significance. All right, there we go. Now, level of significance 0.1, success is 78, sample size 260, and there's 0.26 to represent what we were testing against. And there's the test statistic right there, 1.47. Beautiful. Decide whether or not to fail to reject. So on the right side, then the test statistic would have to be greater than the critical value, or you can actually look at the p-value. I'm not sure if it's going to ask the p-value next or not, but 1.47 would be greater than 1.28, so we're going to reject. But just let's look at the p-value, 0.07. That's less than 0.10, so reject there also. So you can use that information. And which was the claim? The claim was the alternative, the more than. If we reject an all, that means we have evidence. There is enough evidence to support the claim, because the claim was the alternative, and we rejected that hoe. All right, I was hoping it would ask a p-value here on this. Let's look at number 5. Let me sort of look at show completed here, and I want to see what. Okay, good, excellent. This one wants a p-value. So the other one was using critical values. This one's using p-value. That's fine. I've just seen problems in books where they'll do both of them, and which is good too. Both critical value and p-value in the same problem. But this is fine right here. Okay, good. It's also not a right-tailed. It's just something different. Humane Society claims that less than 68% of households, a certain country, own a pet. So less than means it'll be a left-tailed test. And 600 households, 396, say they own a pet. At alpha equals 0.10, is there enough evidence to support the society's claim? All right. And less than 68. And less than will be, right, so it'll be C, less than will be your alternative. And we'll pair up with greater than or equal to. And then we need the test statistic. So we can I'll go calculator first. Stat test number 5. And we're testing this against 68%, so 0.68. X successes is 396. 600 N. And it's less than, so I got it in there right there, right tail test. I'll make sure I make that less than, or we'll never get, it'll get the test statistic right, like I said before, but p-value will not be right. That's okay here. So 2 decimals, I'm looking at negative 1.05. P-value, and like I said, I'll put this in Excel, but since it's right there, we're looking at it. It wants, what did it want, 3? 3. So 0.1468 means I'll go with 0.147. Fantastic. All right, the rule, p-value. P-value of 0.147 is greater than the level of significance of 0.10. So when p-value is greater than your level of significance, you fail to reject. There is not evidence, because the claim, again, it was the claim was the ha, so there's not enough evidence to support the claim, because failing to reject means we don't support the alternative. Wonderful. All right, well, that's the last one. That concludes our video for 7.4, Hypothesis Test for Proportions.